At first glance, it looks like we have a set of three sets of compounds that have similar names. At first glance, it looks like we would name this iron chloride and the compound beneath it also iron chloride, whereas these two compounds would have the name iron oxide and these two would have the name tin oxide. However, we can see that they are very different compounds, that they have different subscripts and therefore have to be different substances. So they cannot have exactly the same names. So what's going on? What's happening here is that the metals that these ionic compounds contain have multiple charges. So when we name these compounds, we have to include the number of the charge in the name. So how do we find out what the charge is? Well, first of all, let's remember that ionic compounds have to have their charges balanced. In other words, the positive charges plus the negative charges have to equal 0. The charge on the cation plus the charge on the anion has to equal 0. To figure out the charge on the cation, it's easiest to do the anion first, because anions only have one charge. Chloride, for instance, always has a -1 charge. And we can see that there are 2 chlorides here. So therefore, the entire charge on the chloride ion would be -2. That means that iron has to have a +2 charge in order to balance this -2 out. So the total charge here, if I circle this just to remind you, is -2 here on the chloride anion. That means that the iron cation has to have a +2 charge. So that means that this variety of iron in this compound is iron 2, and therefore we would name it iron 2 chloride. We use a Roman numeral to indicate the charge of that cation as being iron 2. The example underneath, chloride again, as we know, has a -1 charge. There are 3 of them, so 3 times -1 is -3. That's the net charge on the anion. Therefore, to balance out this total net charge of -3, iron must have a +3 charge over here. So this is the variety of iron with a +3 charge. Therefore, this is iron 3 chloride. So we can see now that these two compounds do have different names because they are indeed different substances. If we go to the next 2 examples, the oxide anion always has a -2 charge. In order to balance it out, this iron must have a +2 charge. So our total net charge then is 0. So this example is iron 2 oxide. The example beneath it, again, we know that oxide has a -2 charge. We have 3 oxides, so 3 times -2 is -6. So the total net charge on this anion is -6. So the total net charge of -6. Therefore, the total net charge over here on the iron has to be +6 in order to get the charges to balance. How do we do that? Well, if we have the +3 variety of iron, 3 times 2 is +6, so our charges would balance. So this becomes iron 3 oxide. At our last 2 examples, we have 2 varieties of tin oxide. Again, oxygen has a -2 charge. That means that this has to be the +2 variety of tin. So this is tin 2 oxide. Over here, as we know, oxide has a -2 charge, but we have 2 of them. So the total net charge here is -4. That means the charge on this tin cation has to be +4 to get our charges to balance. So this is tin 4 oxide. And we can see that they are indeed different substances. So we have to be careful when we're using transition metals that can have multiple charges, or elements such as tin and lead, other metals that can have multiple charges. When we name the compound, we need to use a Roman numeral in the name right after the cation name to indicate the charge on that metal.